Hey guys, Tawfiq here, and today let's write our first metal shader, which displays a triangle that has got different colors on each of its vertices. A metal shader basically comprises two functions, a vertex shader and a fragment shader, and today let's go implement these. Let's open a Cocoa app in Xcode with the language setting of Objective-C. Import MetalKit framework for this project. Let's bring in an Objective-C class and call it renderer. Let's also bring in a corresponding header file. Import MetalKit and also link the header file to the class. Now let's create an interface which inherits MTKViewDelegate's properties. Let's also specify the function signature of our initializers. We start with specifying the metal device, followed by the metal render pipeline state. We bring in the two functions which are inherent to MTKViewDelegate. We also specify our metal command queue an integer vector to carry the viewport size, Now we start specifying the device which we obtained from the delegate. The metal library is defined using the new default library keyword. A vertex function must point to the exact function in your shader class which corresponds to your vertex shader. Now, since we haven't written our shader class yet, let's assume we give it a really simple name. Now the next step is to do the same, but for a fragment function. Now we go ahead and create a metal render pipeline state descriptor. We also give a label to our pipeline state descriptor. Our pipeline state descriptor must also have details on our vertex function and fragment function. Okay, I need to make a correction over here. Before we get into the rest of the other functions, let's go write our shader class. For this, we bring in a metal file and a corresponding header file into our project. Now we write our enum to list our vertex position and viewport size. Now we create a struct to store our vertex position. And also the color. Let's link our shader to the header that we just wrote. We will be using a struct to define our clip space position and our color, which will be handled by the GPU. Now we start writing our vertex shader. We also include in the function signature the inputs that will be going in, such as the vertex ID and the vertices. Now we also specify our viewport size as an input, which will also be coming in through a buffer. Let's not forget our buffer was already defined by our render command encoder. Let's specify a black color for our entire clip space position. Let's also specify the position of each of our vertices to be at the exact same coordinate as we wanted to in our clip space position. We set our viewport to our clip space, and in our case, let's magnify the results. And also pass on the exact color as we mentioned to each of the vertices. Now we're ready to write our fragment shader. At this point, we can go back to our renderer and write our vertex coordinates, colors, and also set our viewport size. We are also yet to specify our render command encoder, which will communicate with our shader. So first let's given our coordinates in clip space, followed by our color for each of the vertices of our triangle. I'm giving different values of red, green, and blue for each of my three vertices, with 1 as my alpha channel value because I'm not doing any compositing here. Now we create our metal command buffer, followed by our render pass descriptor. Given details about our viewport size, now we also specified our render pipeline state. Now create a buffer for our vertex data. Next, we create a buffer for our viewport. And finally, a buffer for our primitive shape. Our primitive shape is going to be populating the vertex values that we've specified. Now we can commit to the GPU this command buffer that we have created. I'm gonna have to correct a few errors that have risen because of me typing too fast. Since we compiled without any errors, I'm going to put my renderer and shader in a folder. Now I'm going to connect my main storyboard to my mtkView class. We are going to write a command queue statement here. When we specify our viewport size in the mtkView method, now we link our view controller to the renderer. Specify our view and our device. Now we give a command to call our renderer. And we view what we obtained from our renderer. Go ahead and build. That's a triangle with different colors on each of the vertices.